Oh, welcome everyone to the Ontology Summit 2020. This summit's theme is knowledge graphs. And the date is January 29th, 2020. And this is the first main session of the Ontology Summit 2020. So today we're going to be giving an overview. We'll be giving an overview. Things are on here. Somebody is not on mute. I guess that did it. Sorry about the delay there. So this is the summit overview. You can all see the slides. So today we're going to be looking first at the theme for the summit, then a brief recap of the fall series. Then we're going to go into the main series, give a little bit about how that series is going to begin. And then organizers of the summit are going to be giving presentations, starting with John, and then Ravi, then Gary and Ram. And after they're finished, I'm going to give a little bit about logistics and the communique. So the theme is knowledge graphs. And as you can see by the logo, we've divided up the subject into 8 kind of focus areas given by these question words: whence, what, why, how, who, where, and when and whither. So in the theme, actually, the theme as specified on the Ontology Summit 2020 page, it goes through some of these. So whence knowledge graphs. Okay, what's the history of those? Well, they're closely related to ontologies and semantic networks and emerged in the last few years. John will be talking a little more about that today. Then what are they? Well, they're basically structured representations of semantic knowledge, stored as a graph, so it's called a knowledge graph. And but they're lightweight versions of semantic networks. Again, John is going to be saying a little more, and Ravi as well. Then why would we bother with these? Well, the idea is that they scale to massive data sets, which are very important today with modern AI and machine learning techniques, as well as the enormous amounts of data that one has on the World Wide Web. Then how are they developed and used? Well, industry is certainly devoting a great deal of effort, and we hope to get some speakers in the series who will be addressing exactly how this is done. And they turn out to be critical to some of the important virtual assistants that we have today. And who are the ones who are using them? Well, a lot. Not just on ontologies, but big data, linked data, artificial intelligence, deep learning, and many others. Now, in the fall series, we basically asked a number of people to speak to give us a kind of idea of what we're dealing with here. And so we had Jans Osman come and give a very nice presentation, and it's available online. why knowledge graphs have hit the hype cycle and what they have in common. Then John gave actually a couple of presentations about knowledge graphs, which he'll be recapping today. And later on, he's going to give additional information about this at a session that I'll mention just in a moment. And then we had a series of 3 sessions by Elise Stickles, who is at the at UBC, British Columbia, talking about metaphor, and in particular the MetaNet repository for metaphor analysis. So that was back in the fall series. Fall series, of course, also involved a lot of planning sessions. Now, in the main series starting today, we classify the sessions according to these question, the 8 question words, but we're putting who, where, and when together as a group and call them the use case classification. So each session will be convened by one of the summit organizers, and there will be 1 speaker. Next week, Chaitanya Baru will be speaking, and Ron will say more about this as he is the convener. February 12th, John will be speaking, and he'll tell us more about this in a moment. Then on the 19th of February, Matthew West is going to be speaking on From Data to Business Value, and I'll convene that, and I'll tell you a little more in a moment. And then on 26th of February, Gary is convening a session, Insights from Knowledge Graphs by Anirudh Prabhu. Now, Matthew West will be speaking on From Data to Business Value, classified in the why part, the why question, answering the question of why. So he's going to do some questions are going to be considered, shown there. Those are just a sample of questions. Then he'll talk about the critical properties of information that are needed, and then applying quality management information. So we are looking forward to a very nice presentation coming up by these 4 speakers, and it will continue on until mid-June. So now I will give it over to John. John.
Okay. Okay, I'll talk about the history of knowledge representation and how it's gone from linear notations and diagrams and relations among them. And starting in the 3rd century AD, the philosopher Porphyry organized his categories in a tree. And that tree is very similar to the same trees that we see every day in all of the ontologies we have today. And actually, he's the one that's given credit for it, but it's quite likely that the similar diagrams were used long before, but they just didn't happen to get recorded in the manuscripts that have survived. Then in the late 19th and early 20th century, Peirce developed a graph notation for logic, and this follows on to his earlier algebraic notation, which became the foundation for the predicate calculus, the most widely used notation. But in the existential graphs, he represented first-order logic, higher-order logic, meta-language modality, and also relationships to and from ordinary language. In the 1950s, Lucien Tenière, a linguist in France, developed dependency graphs, which have a very direct mapping to and from of the various graph notations, including knowledge graphs and everything else. And they're widely used in computational linguistics because they have such a direct mapping to the graphs. In the 1960s, Margaret Masterman was the first person to introduce the word semantic network in her article, and she had a strong influence on Quillian and Shank and others in the 60s. In the 1970s, various people started bringing in logic into the graphs to represent versions of logic, and I list various people. And then 1980s, then we had lots of expert systems and database conceptual schema work, the Psych project, and the standards were being proposed for the Shared Reusable Knowledge Base Project, SRKB. All of this is built on everything that went before. Now, in the 1990s, that's when more statistics started to come into AI, and the neural networks were one of the earliest representations, but they started to get more widely used in the late 80s and 90s, but they still were competing with everything else. The next slide shows the, do we have the next slide? On this, hello, Ken, next slide, number 8. Okay, yeah, the conceptual schema for databases was being proposed in 1978. This is the diagram for the ANSI Spark 3 schema design, and they wanted to distinguish the external schema, which represents the user interface, the internal schema, which represents the way data is stored, which could be either a graph notation or an SQL tables or relations or whatever. And the idea is that the conceptual schema was the ontology that represented the interfaces among the various applications, the databases, the applications, and user interfaces. And all of them, for information passed along any of them, the conceptual schema represented the semantics. And for more information about this, including the references to the original publications, there's a, you can check my web page, jfsowa.com, IKL. And IKL has a lot of, over 100 references to the original data, plus some commentary by me. So you can look for that. And slide 9 is the DAML requirements. These were the requirements written by Jim Hendler, who was the project manager for the DAML project, which became the foundation for the semantic web. And the point is that here is the diagram that he had in the requirement specification, and it showed that the interchange level must support higher order logic, fuzzy logic, and a meld of various representations used in all the applications. And then it also shows SHU as a very simple ontology, and classic is a description logic that evolved into OWL. And slide 10 is shows the semantic web layer cakes. And on the left is the original proposal from Tim Berners-Lee's or proposal. And note the point is that that supports everything in the requirements document, including this big double arrow, which says the semantic web unifying language. And Tim called that SWEL, the semantic web logic level. And that was supposed to be the interchange level among everything. But as the project continued, the version that was delivered in 2005 is a very drastic simplification of what Tim proposed in 2000. And Tim had hoped to continue this and build up more, but the version of 2005 is really what people call the semantic web. Now, there's been more development of notations and such, and some more specifications, but the basic semantic web that we have today is really based on the technology of 2005. And one of the big restrictions on it is decidability, which was not a requirement in the original specification or in the original proposal, but that decidability is more of a restriction. It's not a feature that helps anyone, it's a restriction that limits what can be said. And so then the next slide is a summary of what we have. Slide 11 is a summary that mentions future challenges and possibilities. And the idea of the knowledge graph is to be more readable than RDF and OWL and the other notations, and also more flexible. And there's 15 years of more technology that has been developed in since the end of the DAML project, and people want to have a notation that can map to and from the ordinary language, especially things like Siri and so on. And also, they wanted to map to the new technology, such as the neural nets and a wide range of other kinds of interfaces. And the emphasis is on flexibility, and decidability is meaningless. The idea of decidability is to prove that something is decidable in polynomial time. But any polynomial with an exponent greater than 1 just does not scale to the World Wide Web. So decidability just means nothing when you get to huge volumes of data. And some of these knowledge graphs can be mapped to and from RDF, but others are closer to natural languages. And some are used in a wide range of things, including notations that are very similar to the conceptual schema work of for the databases. And the point that I would like to emphasize is that it's premature to specify a standard for them because there's so much development going off in many different directions that nobody really knows what is the ultimate range of possible applications and what are the best foundations for supporting them. So that's my quick summary.
Thanks, John. So now we'll move on to Ravi. So Ravi, please join us.
Hello?
Yes.
Can you hear me now?
Yes, I hear you.
Thank you. Okay. I went and searched mostly on Google Scholar, Advanced Google, and so on. Continuing from my last few slides on what is a knowledge graph, and found that there is no single agreed definition. But we heard one of the speakers, Hans Assmann from France Allegograph, who said that it is a system that tries to know and learn everything it can about an entity. Of course, there is behind it a use, purpose, product, or process. And it includes a semantic graph, ontologies, taxonomies, and identities. And the techniques use machine learning, NLP, text classifier. This type of pattern will repeat in many of the definitions of knowledge graphs, although I can't say that everyone will follow this kind of sequence. We had also one short slide by Todd earlier, which related to databases and graphs of different kind. John Sowa has spoken to us in many forms on how many types of graphs, but knowledge graph term has really picked up in usage after Google introduced it, which is only one particular way of creating knowledge graphs. So the second reference I found is from Nicola, Rohrseitz. It's a set of data points linked by relations. So almost all people that I refer to, they say you start or you create triples which link data points. He calls them secondary or derivative data sets. Creating the first knowledge graph is significant, but thereafter you can repeat the process to create a set of knowledge graphs. And it does require domain and machine learning expertise as well as technical infrastructure. So we can see 1 and 2 definitions have a lot in common, but they are not exactly the same. Next slide. This is a wonderful, I like it. This is a pictorial representation. I hope we could borrow it for our kind of logo type, introductory type of graph. So here, you can see in the first row a lot of sources of information, text, databases, tables, email threads and messages and so on and so forth. You extract something, grind it out of it, and create some sort of understanding of what it is that we are focusing on. And then you create a taxonomy or ontology. Ontology is what most people like to say about knowledge graphs. Then again you churn it, and then you come out with something looking like knowledge graph, which answers different kinds of questions indicated by this question mark. I really like this better than the one that you will see that I created earlier. 13, slide 14, please. This is another definition.
Hey, Ravi, we really have to get moving on these slides. Okay, so
do I have 1 minute?
try to be a little quicker.
Okay. Well, if we can read, knowledge graph integrates information into an ontology and applies a reasoner. This is what Julian says. Nicola, Murphy, and these people reveal a relational machine learning for knowledge graph. They create a good review. They provide semantically structured information. Almost always there is semantic information. Please, next slide. I am using Magic Chat and I am calling from India with a limited bandwidth channel. So can I speak louder? Does it make better? So it is best if you kindly read if you can't hear me. This is the last one of my slides. There is only one picture after that. This slide follows Peirce's logic. And I know John likes Peirce. This is the last slide. I still think that I stick to my original slide, which was this one in a month or so ago. And that was, we start with tuples and we reach a result. Well, Ken went a bit ahead, but this is the final slide. Thank you.
Thank you, Ravi. Gary?
I'm done.
Yes. Yes, can you hear me? The voice was breaking up on my side, but can you hear me okay?
Yeah, I hear you fine.
Okay, right. Okay, so this particular track was set up by myself and Amit Sheth. Amit has relocated to University of South Carolina from Wright State, if nobody knows, and so he's been a little bit busy. So I've gone ahead and arranged some speakers, and I'm going to be presenting today. But we hope that Amit will be able to present in the future. He and some colleagues have written on the history of knowledge graphs. We thought people would be interested in that, particularly at the beginning. We'll try to work that in and maybe in March. And he has also been sponsoring some IEEE articles on knowledge graphs. So he has a lot to say. Hopefully we'll hear from him in the future. So I note in my particular slide here that we've had many presentations running up to today. You've heard a little bit about some of them from the fall, for example. But in July, for example, when we were trying to decide a topic for the year, I was asked to present a case for knowledge graphs. And so the link that you see on the top there is actually my initial slides for justifying this as the topic. I will reuse one slide from that particular deck. As you've heard, there's many rationales for why we would do that, to enforce semantics, better semantics in our applications, to improve search and so forth, integration of data. And to some degree, that's why I have the Dagwood Bumstead animation or cartoon on the right side, which is the idea that knowledge graphs get used for lots of purposes, and because of them, they have lots of different things in there. You saw a little bit of that on Ravi's slide, and I have a slide a little bit like that. The real issue is whether the structures fit together and if it all works right and tastes right for us. I note also on this particular slide that, and this was again from our earlier presentation, that formal ontologizing offers great degree of help for knowledge graph work. For one thing, it improves the expressiveness and the quality of knowledge that goes into a knowledge graph, provides better knowledge organization for the graph, and it provides better support for reasoning. And also we have ontological knowledge engineering practices. I note also that some of these particular ideas have appeared in earlier summits. Last year, for example, when we were talking about explanation, Thorsten Hamann and I had a track on common sense, and we had people like Nick Tandon talking about common sense in knowledge graphs and the help that gives with explanation. Next slide, please. The next slide that you see now, I thought I would throw into the hopper here, because at the very beginning of the ontology summits back over 10 years ago, the idea of the ontology or the semantic gradient and spectrum was an interesting organizational idea. If you're not familiar with it, what you have here, and it's a little bit hard to read, of course, lots packed in here, you have a hierarchy, a spectrum, as it were, going from things that are very informal, have informal and weak semantics, things that you might have in a dictionary or maybe in a taxonomy, which is a little bit more organized. And as you move up the spectrum, you get into things that are more semi-formalized, like RDF and so forth, until you reach the top when you have various forms of formal logic and you have descriptive logic in there. And so this provides a little bit of a vision about what we've been working on for a number of years and talking about. And what I wanted to do in this diagram is to say that and show that knowledge graphs are sort of off that spectrum because they combine various parts of the spectrum. And going back to the Dagwood-Bumstead cartoon, the idea is that the challenge really is to pick the right things and to harmonize them up and down that spectrum. And within knowledge graphs, you may have very diverse things that require a lot of harmonization. And again, some of our ontological engineering may help with that very task. Next slide, please. This next slide is a reproduction from my original presentation. And it is a much more complicated version of the nice diagram and the neat diagram that Ravi showed before, which is the idea of what's going into a knowledge graph. And so just very simply on the upper level, going across from left to right, we have a lot of these ingredients, from the informal, relatively informal things like keywords and so forth, things that are in tables, to more structured things in relational databases and RDF and so forth, until the very structured things on the right, Freebase and so forth, things that are out on the World Wide Web coming into it. And you see, of course, all that being integrated into a graph-like form in the middle, but it is important to note that on the bottom level, you have the role of domain ontologies to actually improve the quality of all this thing that's getting mashed together inside here. And as it says in the yellow box at the bottom, efforts for communities related to deep learning, knowledge graphs, and natural language processing join their forces in this arena of knowledge graphs in order to develop more effective algorithms and applications. And that is indeed part of the inspiration for the track. Next slide, I'll introduce the sessions, the 2 sessions that we're proposing. The session plan, of course, we have this introductory track now, and then as Ken noted before, our first session in February, the 26th, will be Anirudh Prabhu from RPI, who presented a very nice slide presentation called Insights from Knowledge Graphs. So he is going to be presenting that, maybe a little adaptation. The feature of that, and you'll see a little bit more on the next slide, is that we gain this very complicated Dagwood-Bumstead type of thing, everything in there. We gain insight into what the knowledge graph is and can do from a variety of other things like reasoners on it, or visual analytics, or network science approaches to understand the knowledge graph and to improve it and so forth. I note there that Anirudh is working under Peter Fox at RPI and working on data modeling, e-science, and so data visualization. Our next session will be sometimes in March, and that will be, sorry, you jumped ahead. At the bottom of this slide 21, Paco Nathan, he's a managing partner at Derwin, will provide a talk on the Rich Context Project. Now you can go to the next slide. The last 2 slides are just gives you a little bit of a picture of what our speakers are going to be presenting And so you can see a little bit of the type of things like web vowel and so forth that Anirudh will be talking about, which it provides some visual analytics for knowledge graphs. And my last slide is on Paco Nathan. So this is a little bit more about Paco's work on the rich context projects, which is, as it says here, intakes metadata from agencies involved with the administrative data to build a knowledge graph of metadata about data usage. And on the right, there are a variety of things he will talk about. He's very good at all of these things, and I particularly like his discussion of deep learning and machine learning, which he's an expert on, you applied with knowledge graphs. Okay, that completes my presentation.
Thank you, Gary. That was great. So now, if Ram is on.
Can you hear me?
Yes, we hear you.
Okay. Yeah, so I am going to kind of present the speakers who are going to talk on a variety of things from whence to why to how to what, whatever, the kinds of things which are presented on the top left-hand corner. First speaker is Chaitanya Baru, who's going to talk about on the whence part of it. He's the senior science advisor in NSF, and he advises NSF on this open knowledge network. Now, open knowledge network is I think it's approximately $40 million or so, I'm not sure. It is in several phases, and it's part of the National Science Foundation's convergence projects. So if you go to their website, you can find the details about these things. They're called Convergence Accelerators Projects, or CAXL projects. And Chaitanya advises on these projects, and it's particularly on the Open Knowledge Network, which is a track A1, and it's to deal with harnessing the data revolution aspects of NSF's future funding. So he is going to be presenting on February 5th. Then Ernest Davis, who some of you might have read his book called Rebooting AI, has been working on representing common sense knowledge since his PhD thesis. And the book Rebooting AI actually gives really great insights on the current limitations of these deep neural networks and what are the problems associated and how do you need to augment it and what do you need extra to add to it and things like that. So I'm sure that we're going to get some great insights from Ernest Davis on various aspects of the case for knowledge graphs, or whatever he calls them. Next slide. Then we have several people who are going to talk about, several of these people who got this open knowledge net, the NSF's open knowledge networks preliminary phase 1 grants are going to talk later on. Jay Pujara is going to talk on the financial use cases. Now, some of these dates have not been fixed, and Ken is working with these people to fix the dates depending on availability and things like that. And Jay is a research assistant professor at USC ISI, and his research kind of focuses on knowledge graphs, formalism. I believe he did his PhD at University of Maryland with Lisa Getour, who actually gave a talk on probabilistic networks some time ago in our forum, I believe, okay? And he received this NSF OK in phase 1 proposal, leveraging financial and economic data. And Jay has also given several tutorials at AAAI on knowledge graphs, so he's pretty well versed in this subject. Then we have Chris Mungal in the biomedical domain, and is head of the molecular ecosystems biology group at Lawrence Berkeley National Lab. And I think it's a Livermore, I'm not sure, I think it's a Lawrence Livermore Berkeley National Lab. And he also is one of the leaders of the Gene Ontology Consortium. And then the Monarch Initiative, which actually does phenotype comparison across species using ontologies. Like, for example, you want to map between the rat and the human species. There are some ontologies in both the species which are kind of common, and you can map across that thing, and it's very useful. So again, I think we're going to get some very interesting aspects of knowledge graphs from him. Then we have Vinay Chowdhury, who actually initiated this this project several years ago when he was in SRI. And the idea is to kind of read biology textbooks, especially Campbell's biology textbook, and the system can answer various queries associated with that. it's a massive project of encoding the entire knowledge of biology essentially using the knowledge graph paradigm. It was kind of successful to a certain extent, but it was funded by Paul Allen at Microsoft, and then I think later on that funding was taken out for whatever reasons. David Gunning was involved in that, and David Gunning moved to DARPA, so that was the end of that graph. But then he's still been working on that, and he's a co-investigator on NSF OK and Phase 1 proposals on intelligent textbooks. Now the idea is that now you take all this knowledge in textbooks and somehow build knowledge graphs out of it, and then you can do intelligent Q&A on these textbooks. In the world of manufacturing, we have Benil Starley, who also got a Convergence Accelerator Phase 1 grant. He works at North Carolina State University, and his primary research area is digital manufacturing. Next slide, please. Then we have Iswaran Subramaniam and Spencer Briner, who have been working at NIST on the category theory, and their focus is on representing knowledge graphs using category theory as a paradigm. And now if you look at the ontology spectrum, which Gary Berg kind of showed, there are different kinds of representational formalisms. And the claim here is that category theory actually will encompass all these things, and you can represent a whole wide variety of knowledge, both from the engineering pieces of knowledge, like for example, when you say F equals ma, which is a Newtonian laws, to predicate calculus and those kinds of things can all be represented in category theory. And I believe Ken Bakrowski also is going to talk about it later on. So we have two presentations in this area, I believe. Next slide, please. And there are several speakers whom I have been in touch. They're potential speakers who have, some of them have agreed, some of them I'm still talking to them. Olanda Gill, who is the president of AAAI, is kind of busy with her presidential address, which is going to happen in 2 weeks. And she said she will be willing to give a talk later on in whatever year, maybe May, June timeframe. Sargur Srihari, who actually gave a talk on probabilistic networks last year, has not got back to me now. He's in India at this stage. Guha, I've not gotten a response from him because he said he missed my earlier email and he'll get back to me. And I think Ken presumably is following up on this thing. We might be able to find a slot for him because he has really, in fact, it would have been great if he was the first speaker, but somehow I guess my email went into his junk or whatever it is, and so he missed it totally. Then Sean Gordon is going to come back again. Luciela, absolutely no reply from her at University of San Diego. She's in the biomedical domain, but I'm following up on that. T.N. Butt at Sean Gordon said that he's not the expert on spatial decision support, but he'll have one of his colleagues to talk about it, and that will be again at the later half of this summit. T.N. Butt at NIST has got this interesting project called Rule and Rule-Based Technology, where you can actually generate the terminologies and generate knowledge graphs automatically from text. That's the idea here. Like instead of encoding knowledge graphs for example, the intelligent textbook, here this one, with this technology, you can automatically generate knowledge graphs, terminologies right now and later knowledge graphs. I think that's all I have for now. I finished my 5 minutes.
Thanks, Ram. That's really an impressive list of speakers. Now, the communique is going to be basically a kind of summary, which we're going to submit to the Journal of Applied Ontology. As a result of the need for a communique, we're going to have 2 synthesis sessions. I believe the first one is tentatively scheduled for April 1st, and the second one in the beginning of June, or actually toward the end of May. But those are still tentative. And then a couple of sessions that are devoted to creating the communique itself. We will then present the communique at the symposium to be held tentatively around the middle of June. So for those who have attended previous summits, it's a good deal later. This symposium will be quite a bit later than we've had in the past. So now, logistics. Our plan is, maybe not this week, but in later weeks, we're going to try to keep the presentation to 30 minutes. So we have 30 minutes for discussion. And but on some occasions, if the topic is sufficiently rich, we may schedule with advance notice a 1.5 hour session, up to 1.5 hours. All the sessions will start just like today at noon Eastern time, and they all have meeting pages already created on the Ontolog forum website. So there's some supplementary slides here that Gary provided. I won't go over them. I don't think Gary is planning to either. What we'll do now is open everything open to general questions. So if you unmute yourself, let's see, do we have anyone's hand up? No one's hand is up. If you wish to ask a question, preferably click on the hand icon on the chat, or just you start talking.
Ken, can I make a point on, Bob had asked a question about the grouping of our contextual questions, and it, I think, bears explaining that when we came up with this structure, we particularly wanted to cover the whence, why, how, and whither in depth. So we wanted to get people who could give a primary focus to each of those separately. As Ken said in the chat, of course, everybody will be addressing all of the questions to some extent. The what we also deliberately wanted to leave, have some preliminary ideas right now in the kickoff, and just to sketch some of the landscape of what. And then in the synthesis sessions, we will collect what we have learned and revisit what. That left the who, where, and when, which don't really warrant separate sessions focusing on them. So they clump together in sort of a realized use case, loosely speaking, focus. So that's the logic that we used.
Thanks, Janet. Any other comments, Janet?
No, I'm thrilled. This is coming together really well.
Yeah. Any other discussion going on in the chat? I believe there's also a discussion going on in the Zoom chat.
Jack Ring here.
Jack, you were involved in that.
I'm struck by the conversation today because it seems to be about 80% concerned with stored program computers and how to apply them to human understanding. And it seems to me that there are some other methods now being demonstrated that use different kinds of hardware and showing 1,000-fold increases in speed and reduction in energy, etc. So I'm wondering whether we shouldn't have some material on the notion of knowledge graphs simply as facilitation of human communication rather than going into computer-y stuff immediately. Thank you.
Thanks, Jack. Let's see, anyone else in the?
Kenneth?
So Todd, you had some comments?
Well, I'm just, I'm a little confused. I'm not sure what Jack has in mind when he talks about what was it, something storage computers? What sort of technologies or capabilities do you have in mind, Jack, when you make that reference?
Well, in the chat column, I've given you a couple of URLs or contacts. One is a company that's now in its 3rd year and is out public, called Pattern Computer, in which we find relationships that no human being had ever perceived. For example, in breast cancer, we have found many very significant relationships that the whole ontology community had never even thought of. And that, by the way, is a software implementation on stored program computers. But secondly, I've referred you to a little naturalsemi.com, which is a 7-layer chip that it reflects a patent of Kurt Harris that does not use any stored program, any storage for analyzing a milieu of data and finding all of the possible relationships between each entity in that milieu. And that is, we already can see that 1,000-fold reduction in runtime and wattage is entirely possible. And in fact, wattage is the big problem right now in knowledge graphs with stored program computers. Keeping the computers cool is a major expense.
So Jack, in these other mechanisms, they are not persisting the knowledge in some fashion, some representation?
I'm sorry, I didn't understand.
Well, it somehow in these other mechanisms that you do, are they persisting that knowledge in some fashion? Or I don't understand. Somehow the notion of the notion of knowledge necessarily entails some ability to persist it.
Yes, but it also entails the ability to recognize when it's no longer valid.
Yeah, but
right. So
well, I guess the point or the confusion I have is you talk about these stored program mechanisms. Well, I guess I'm ignorant of these other types of tools or machines that you're making reference to, and I'm just trying to learn as much as I can from you. I'm being lazy here.
John, John might have some comments about this.
These chips.
You still online?
These chips use the same operands as OWL or RDF. It's just that they have a better way of discovering all the different kinds of relationships among those entities.
Oh, okay. Also, I copied one of your Zoom chats into the Soap Hub chat. Are there other URLs that you could point us to? And if so, would you put those in the Soap Hub chat, not the Zoom chat?
I can put them over there, I think, or Janet certainly can.
Okay, thank you.
Thank you for your interest.
Okay, we have Ravi has his hand up.
Yeah, I just put a question in the chat because my sound may not come, but essentially the idea is, are we going to see someone create a knowledge graph from data points and relationships or from NLP entities during the meetings?
Well, we've had demonstrations. Jan Assmann did give a demonstration. I would hope that we would see some demonstrations at some sessions.
Good.
But it is a big subject, and with only 30-minute talks, I imagine people might not have enough time to go, to that level of detail. But we'll see. We'll see what we can get.
Yeah, I'm hoping somebody will say this is how we construct it and show some steps, like the graph that one saw today.
Yes, I hope so. John has his hand up. John, can you unmute yourself?
*6.
I would unmute him, but I don't know what his telephone number is. All I see is a telephone number for John.
How about the 914 number? Is that the area code for?
Hello?
We got you.
Yes,
Okay.
John. Good.
Yeah. Okay. The basic point is that it doesn't matter what kind of computer anybody generates or what kind of software anybody uses or hardware or whatever, we're still going to talk about it in ordinary language. And so the fact is that it'll still come in and out of through our telephones and our cell phones and our good old-fashioned computers. So the point is that you can invent all kinds of new technology for discovering new kinds of relations, but as soon as you discover a new kind of relation, you give it a name, and then you can talk about it in ordinary language. Now, one of the things that's very important are the mental models, which reflect the kind of scenes and pictures and sounds that we experience. And those are the things that are really the primitives for all of our ways of thinking. They're more fundamental than language. They precede language by at least a year or two in infancy. And those, and they're with us throughout our lives. The experiences in our mental models, those are our fundamental ways of experiencing the world, and then those things can be given names and mapped to ordinary language. So we're still going to use that in everything we say, and no matter what anybody invents, if they create new kinds of discoveries and new kinds of relations, we just give them a name. That's what happened with quantum mechanics, for example, and the Big Bang and all kinds of things out in the universe. They were discovered through mathematical methods that aren't explainable in ordinary language in any simple way. But the point is that as soon as anybody discovers it, they give it a name, and then they can start talking about it. So that's what we'll still be using. No matter how long people will survive, they'll be using ordinary language.
But what the name implies to two different human beings can be quite different.
That's true of every word we use. No two people have exactly the same meanings for any word. But the point is that we always can ask a question. That's why you always need a follow-up question, and just a system that just gives you one answer is not adequate. What you always need is to say, what do you mean? Is this an example of what you mean? Can you give me an example? Can you explain it? So we always need to be able to have follow-up questions. And what happens is through a dialogue, we collaborate the terminology we use. So an official standard for anything is something that's necessary for if you're going to write a program. But when you communicate with another person or with a computer, you're always going to be communicating in terms of your own language, and the other person or computer you're talking to will not be exactly in sync, and so you have to have a dialogue, and the dialogue is what synchronizes your meanings.
Excellent. So where is the topic dialogue in this interchange?
The topic dialogue is whatever you
about
create.
RDF and OWL and all this crap.
No. The topic dialogue is whatever you create in your dialogue. So, like you and I started with different meanings. We had some sort of interchange in which we adjusted each other's terminology so that we could communicate. That's the way you're going to compute.
Did we conduct a dialogue?
Well, you've been talking and I've been talking, and we've both been listening to what's been going on. So throughout this situation, a lot of people have been talking and listening and writing and reading, and through this communication, we've adjusted the way we're talking and what we're saying in order to communicate. That happens all the time.
Well, I agree, and I think we've had a little dialogue because I've learned a lot about what your viewpoint on this, and I respect it. My question is, where is the topic dialogue in this communique?
Jack?
It isn't
That's
about
something we'll
just
have
RDF.
to have. Yeah, we'll have to
Jack?
add that.
Yeah, I think, yes, we can add it. And I think we should keep that in mind for maybe next year, maybe getting broader and deeper on the question of language and the dynamic development of representations and, as you're saying, persistence has positive and negative aspects that here in COSI IW, the International Council on Systems Engineering International Workshop, which I'm still attending, we had some discussion on patterns and patterning, the process of patterning, and in terms of Persian understanding of language and moving from the indexical to the iconic to the symbolic. And I think it would be interesting to maybe get into depth later. I really like the setup that we have here for this summit, but I think those are good points you're making.
To reinforce John's point, I would like to report that we found out a few years ago that when starting to design a new system, the best way to do it was to draw cartoons on the wall, no text whatsoever. And so the set of cartoons were intended to communicate what the system was supposed to accomplish.
Right, and that's
when we do that, the project went way, way faster, and people understood each other way better than arguing over terminology.
Yeah, that's a really good point, because that's the indexical level of language. I'm sorry, the iconic level of language, or indexical, but it's not the symbolic. The symbolic is where you start getting lost in the representations.
Well, that's an interesting point about cartoons that Wittgenstein said in one of his comments, that you could write an entire textbook on logic consisting of nothing but jokes. And basically, that's true, that the jokes are the things that lead you to a new conception that wasn't in your pattern of thinking before, and it breaks that pattern to create new patterns. And basically, a sequence of jokes is a good way to present your philosophy.
Excellent.
There's been a discussion on the chat room with Mike Bennett and some others. Mike, are you still there?
Yeah, I'm here. Yeah, I was just tipping and here and there. So I commented earlier that I really liked the early Tim Berners-Lee stack, which I'd never seen before, that showed different levels of logic, the first order and higher order and so on, because it worries me that in some circles, this idea is getting prevalent that to be an ontology is to be first order and to be OWL and, to be decidable and so on. And that is, of course, a very useful artifact. But understanding how meaning works, and in order to be able to document more things about the business problem domain, you do need to be able to talk about those higher orders of things, which actually kind of brings me along to my comment just now on the back of John's stuff, which is, you're describing the later Wittgenstein language games and so on. And of course, in our understanding of how language works, that supersedes the whole Russell and Whitehead type of stuff of being able to do it all in logic. But for useful applications that you can put in knowledge graphs and do something computational with, we're kind of still with Russell and Whitehead. And that's not necessarily a bad thing, as long as we understand that is not how meaning really works, in the same way that Dr. Johnson's dictionary is not how language really works, but became a useful artifact for helping us lock things down.
Yes, that's important. And but the point is that to get back to Wittgenstein's language games, every language game could be expressed in first order logic. The problem, though, is that you have to be able to switch from one game to another. Sometimes you might even refer to 2 or 3 different language games within a single sentence. And that means that you need to have a meta level that you use to relate all the different object levels. So you can still represent your object level in first order logic and map that in to and from your computer program, but then you need to jump up to the meta level where you then talk about how these different object level versions relate to one another and to the real world.
That's a really valuable point. And to me, there's a parallel there between that and having different application data models, including different application OWL ontologies for different use cases, where you extract from the sum of knowledge that there is just what you need for that application to solve that particular problem. And so perhaps we can think about, you know, the ecosystem of applications within an organization as being like those language games.
Yes, and that's important also for any kind of an implementation. And the thing is that we're never going to be able to implement all of them simultaneously, but we need to have some way of moving from one to another. And that's why I think that ordinary language and just a typical dictionary that you can pull off your shelf is far more valuable for relating multiple language games, because it represents the sum total of everything that lexicographer happened to come across, or that family of lexicographers happened to come across in analyzing a huge corpus of data. So that the dictionaries represent your common average usage, and that's a useful starting point for moving to any particular detailed usage.
Yeah, agreed.
Okay, we've run out of time, so I will now adjourn the meeting, and I hope all of you will come to all of the sessions. So hope to get a lot of discussions like the one we have today, and so see you all next week.